Hello, my name is Manish Gupta. I work as a principal applied scientist at Microsoft. I also work as an adjunct faculty at IIIT Hyderabad and as a visiting faculty at ISB. I thank the organizers of the Amazon Research Days for inviting me. Today I'm going to talk about designing a query auto-completion system. So let's start. Here are some examples of auto-suggest or query auto-completion system. Users type in short prefixes like FAC and they see suggestions as a drop-down list, right? Sometimes users are also shown various kinds of entities, while other times they're just shown plain suggestions which they can click on and look at the search engine results page. Right? So if you look at this example at the bottom, the user has started typing in D and then probably is looking for deep learning or Deepika Padukone and so on. So essentially, the user continues to type next few characters until they get what they are looking for, and then they click on the appropriate suggestion. The small thing, the partial query the user has typed in is called as a prefix. And then what the user is shown for the prefix is called as a block. And the user may be engaged in a conversation with the system until the user gets what they're looking for, and then they click and look at the search engine results. Right? The autosuggest problem is pretty complex. If you look at the search problem itself, the search problem is about guessing what the user has in mind, which the user tries to express in term of a search query. So the search engine has to really guess that particular intent and then show the search results. In case of ambiguous queries, this guessing is may not be perfect. So for example, user might be looking for Apple stock prices, but then the user just types in the query as Apple, and then they see results as these, which is not really matching the intent of the user. Now, this is called intent gap in search. Intent gap is very high in autosuggest. Guessing the user intent with very short prefixes makes it super complex, especially when you don't know the exact language that the user may be using, right? So guessing user language using very short prefixes is complex, and guessing incorrectly could lead to defects, could lead to misspellings, could lead to inappropriate suggestions. In fact, it could also very well lead to freshness or local tail intent related problems. So in short, the goal of autosuggest is to suggest the user's intended query after minimal inputs keystrokes. So we want the user to type as less as possible and still be able to get what they're looking for. And the idea is to really rank the user's intended query highly in the completed suggestions with as less keystrokes as possible. Now, with that goal in mind, here is the agenda for my short talk today. We'll be talking about how to rank suggestions, then how to handle defective suggestions and prefixes, generating suggestions and personalization, and then I'll quickly summarize with a summary and a quick note on future trends. So let's start with ranking suggestions. The most popular way of ranking suggestions for autosuggest is to use something called as the most popular completion. It basically uses the wisdom of the crowds. So using a large query log, one can actually rank candidates by a function of its past popularity. If a candidate suggestion has been queried for a lot of times and it matches with the partial prefix that the user has typed in, you show that one at the top. Right? So typically this is supported by a trie data structure, which indexes all the historical popular queries. One has to be also careful about being specific to the language the user has selected. So while some kind of queries may be more popular in some language, in some other language, which follows similar script, or maybe following maybe something like Indian languages, which people type in Roman script, right? You have to be very careful about the language that the user might be trying to see suggestions in. Next, you have to be also careful about region-specific popularity. So while certain queries starting with some prefixes might be more popular in one region, in another region, they may not be as popular, right? Now, when computing popularity, one has to, of course, aggregate over history, but how long the history? Typically, people give more importance to recent history and lesser importance to past history, but the dampening function has to be really very specific to the kind of queries that are coming in. So maybe it's a good idea to vary the query log aggregation period over which you compute the popularity specifically for, let's say, the short prefixes versus long prefixes. Now, lastly, you may also want to rank these previous historical suggestions by clicks rather than just impressions in the past. However, one has to be careful because click data is often sparse, so it may not really work well in all cases. Suggestions that are recommended should also be time sensitive in nature. So there are different kinds of queries, like there are predictably popular queries or unpredictably popular queries, right? So for example, so predictable popular queries include queries which are temporally recurring, and therefore you can predict that they'll be popular at a particular time period, or they are about known foreseeable events, for example, certain festivals and so on. Yeah. And when you know that, hey, they are going to be popular, then it is better to actually show those at the top, even though their historical popularity may not be as high. For example, if somebody is typing HA in October, Halloween might be the right suggestion to show at the top. However, in other time periods, maybe Harry Potter is the right suggestion to show at the top. Similarly, on weekends, maybe it is a good idea to show Disney at the top, while on weekdays, maybe it's a good idea to show other things like dictionary or direct TV at the top. Now, there could be other queries also which are unpredictably popular. For example, in January 2012, Sarah Burke actually got bursty versus the usually popular Sarah Palin. And then in those cases, one has to also be careful about showing what is trendy and what is popular now, rather than only showing things that have been predictably trendy or just usually trendy in the historical in the history. Also, it probably is a good idea to actually rank queries based on forecasted frequencies, where forecasting can be done using various time series modeling methods like ARIMA or exponential smoothing, while merging this kind of a signal with the actual popularity in the past from the try. Now, location sensitivity is another important thing. So a user who is in San Diego and types UNI can be shown University of California, San Diego, but it's not okay to show University of California, Los Angeles, right, to that particular user. So location sensitivity of queries is super important. Accordingly, in fact, there are two types of queries. As you see here, there are some queries, which are super popular in a particular area, right? And these are called as local interest queries. So queries which are interesting to users at a particular location. They could be about a local football team or a local high school or a local newspaper and so on. Well, on the other hand, there are some kinds of queries which are localizable queries. For example, generic queries like Pizza Hut. Now, when somebody types in Pizza Hut, maybe showing up Pizza Hut San Francisco at the top is good if the user is from San Francisco, versus showing Pizza Hut Bangalore is good if the user is from Bangalore and so on. Okay. So location sensitivity is another thing to care for when you're ranking suggestions. Now, of course, another important thing to care is personalization. So a user who typically searches for books and types in the grade, yes, you could basically show this particular user other books that start with the grade. But then consider another user whose session history shows that she has been typically searching for movies. That's a good idea to show movies that start with the grade. Again, if you look at yet another user who has been typically a movies user, but then very recently she has been planning a trip to Beijing, right? As you can see from her very recent query. Then maybe when she types in the grade, it's a good idea to show the Great Wall of China right at the top. So leveraging short-term, long-term history signals and other kinds of signals for personalization is also a great idea when trying to rank suggestions for autosuggest. Another popular feature in Autosuggest is this thing called as ghosting. So if you're super confident that the top suggestion that you have come up with is going to be the thing that the user will really click on, it might be a good idea to just autocomplete in this interesting user interface gimmick where you autocomplete a search recommendation by highlighting that suggested text in line right inside the search box. Now, it has been shown that if you do this kind of ghosting, it increases the acceptance of the offered suggestions by a substantial amount, right? It also reduces misspelled searches by a significant amount. It sort of overall increases the engagement of users with autosuggest system. Autosuggest could also leverage session co-occurrence data as an important signal for ranking. Let's say over several analysis of several sessions in the past, you've observed that after Richard Nixon, people actually query for American presidents. Then when the current user is typing in, they have typed in Richard Nixon and typing in AM, you can actually directly show American presidents right at the top. Now, this data could have some sparsity because, hey, not many people may be typing exactly the same pair of queries, in which case you could try to come up with similarity, which is syntactic or even semantic. So if a lot of users have been typing in American Airlines and then American Airlines flight status, now there may not be too many of such people, right? But then lots of people may be typing in American Airlines followed by some other airlines. And then you realize, hey, Continental is also an airline. So there's semantic similarity. So you could practically, show Continental as a suggestion right after the user has typed in American Airlines. Or you could also show semantically similar stuff. So rather than showing American Airlines, you may want to just show Continental and Spike and so on. Okay. Yet another way of ranking suggestions is using non-prefix matches. So if the user has typed in some prefix, and then you may or may not have very good suggestions coming from your prefix match-based try, in which case you could show some suggestions which match some of the words the user has typed in, but may not be exactly prefix matching. For example, in this particular suggestion, there is yet another word added. And similarly, if you look at the second suggestion, you see that some of those original words are retained, but then they are not retained in the same order. Okay. Of course, to be able to support such kind of a stuff, you need to support this using inverted indexes, and the typical tries don't work. But it's a nice idea of augmenting your current prefix matching based system with non-prefix matches. People have also tried to use machine learning for ranking suggestions, and they have used various kinds of features for learning such traditional machine learning classifiers for good ranking. So these features include prefix-based features. Does the prefix end with a space? What is the length of the prefix? Or suggestion-based features, what you're planning to show in the ranking list. So what has been, of course, the historical impressions, it's the navigational query, number of queries with this suggestion as the prefix, several kinds of interesting features. People have also used pairwise features which relate the suggestion that you're trying to recommend with the previous query in the same session. So that's typically called as the anchor query. So the idea is that this next suggestion should be somewhat similar to the anchor query, and therefore you can come up with the features like co-occurrence frequency of the anchor query and candidate suggestion in your background data, or edit distance, or number of sessions with anchor query, terms added, dropped, or anchor query is clicked or not, and so on. Such kinds of interesting features. You can also compute features keeping the entire user session in mind. So take the current user session and find out what is the similarity or what are the common words between the historical queries in this session versus the current suggestion, right? So number of use terms, how many times these terms have been repeated in the session, average time gap between queries in the session, all of those are sort of interesting session-based features to be used for learning such machine learning-based classifiers. You can also use user features. For example, some users who type very fast tend to look at autosuggest only when they have completed a particular word rather than looking after every character. For such users, maybe it's a good idea to show suggestions after, show more high quality suggestions after a word ends versus showing quicker suggestions after every character and so on. So, well, there are other kinds of features that are more meaningful, like suggestion frequency in short-term, long-term history of the user or other users of the same gender and so on. Recently, neural methods for ranking suggestions have also been proposed. So these methods basically use popular sequence learning based methods like RNNs, LSTMs, and they could be trained in a autoregressive manner. So next word kind of prediction kind of manner, or also in a learning to rank manner, where you try to rank those suggestions which are clicked higher compared to those suggestions which are not clicked in your labeled training data. That was about the first part on ranking suggestions. Now, let me start talking about how to handle defective suggestions and prefixes. Remember, before you're building the try, you may not want to put in everything that the users have searched for. Users search for nasty things, and therefore it is very important to keep your try safe from such defects. These defects could include several things like spelling mistakes, offensive suggestions, partial suggestions, some really rare intents which you don't want to really show to your users when they type in those prefix of those kinds of suggestions, right? Uh, Nonsensical suggestions, hallucinations, right? So, or even offensive ones. So these kinds of things, you don't really want to show these kinds of things to your users, and therefore it's important to protect your try from not having this kind of garbage itself before you start showing it as part of autosuggest, showing suggestions as part of autosuggest. So several deep learning methods have been proposed in the literature, including this one, which basically encodes your suggestion using word vector embeddings, and then uses CNNs on top, further followed by LSTMs, so as to finally predict if a suggestion is nasty or not, right, defective or not. And then, of course, there are methods which basically take this one to the next level by bringing in multilinguality, right? So support defect prediction for multilingual suggestions. So that's great. So you have basically taken care of those suggestions which are nasty, and you have removed them from your try. However, sometimes users type in misspellings, right? You don't want to completely delete them, but maybe spell correct them and then include them in your try. However, how do you do spell correction is a widely studied problem, right? People have been studying spell correction for search engines for a long period of time. Recently, people have started using neural methods. So spell correction problem is a sequence labeling problem. You basically start with a sequence and then you want to get another sequence, which is almost the same size, but then some words may be changed here and there, right? Only a few characters may be changed so as to get a spell corrected sequence. Yeah. You may think that you could use BERT to do this because BERT has been trained to correct things. Remember muscle language modeling? However, BERT is really bad at detecting errors. It is really good at correcting errors if you tell it that, hey, here is an error, but it's really bad at detecting errors. Therefore, people have proposed something called as softmax BERT, where the idea is that you have two networks here. One is a detection network and the other is a correction network. The detection network, in fact, in this particular case, is a bidirectional GRU, which tells you for every character what is the probability that the character is misspelled, is wrong, right? And then you basically mask that particular character with the masked embedding, or with the remaining probability, you continue to use the original embedding of the character and pass it to BERT. So this correction network is basically BERT, which essentially takes your soft masked embedding and then tries to correct it. So and then tries to predict the corrected form of the word, right, or of the character. So of course, this has to be trained using two losses, one detection loss and the correction loss. Have you detected the the character which was misspelled? And have you also correct nicely? Okay. Now that is all good. So you can do it all offline. However, how about misspellings that happen when the users are typing in prefixes and they make mistakes while typing those prefixes? How do you handle them? Now to handle those, it's called online spell correction, and that is really required because users can actually do spelling mistakes for several reasons, with typing very quickly, or keyboard adjacency, of course, fat finger problems, and so on. So what you want to do is, the user is typing in prefixes of this kind, you want to at runtime correct these prefixes to maybe, in this particular case, a corrected one, right? Or if the user had typed in FACBO, you want to quickly correct it to FACEBOO so that you can actually show a nice suggestion from the try. So the idea is to do these kinds of things, you have to basically take your try and also have some sort of conversion rules that, hey, if you really converted CBO to CEBOO, what would happen? So how much should the conversion cost? The idea is to move from one node in the try to another node in the try by incurring a conversion cost for a conversion rule. Right? So now, of course, these conversion rule tables have to be learned. And then you could say that, hey, CBO to CBOO, I could actually convert by incurring some sort of a cost. With that cost, you basically combine it with try scores and then try to see if after you make the correction, you will get more promising results from the try. And then you do that spell correction. So those were some of the ways of handling defective suggestions and prefixes. Now, let me quickly talk about how to generate suggestions and personalization. Now, while ranking suggestions from the try, spell correcting them, and so on is great for head kind of queries, for longer queries, for tail kind of queries, it is super complex to get anything meaningful from the try. In those cases, one can leverage recent advances in natural language generation, both deep learning based as well as non-deep learning based, so as to come up with some good suggestions and not show empty blocks, right? For example, if you take such long prefixes like how to get from San Francisco to LA by, now typically in your try for such long prefixes, there's not much data, right? People have not queried a lot with these kinds of prefixes. And therefore, you may end up showing nothing. And to improve on this tail recall, it's super important to actually generate some suggestions using the natural language generation mechanisms, as we'll discuss in this part of the talk. There are several technical challenges to do these things. Autosuggest is typically a high latent, it's supposed to be a high throughput system. So one has to be very conscious about latency. Of course, since you are talking about tail, you cannot go bad on your suggestion quality. At the same time, you have to ensure that your model is super compressed, right? So that you can actually deploy it with low latency. So you must distill your model. You cannot afford to do beam decoding. Therefore, you have to do greedy decoding. you have to somehow also handle partial words in the input that are coming in while generating using traditional transform-based models, which have a subword vocabulary, and your partial word may or may not match with the subword boundary, right? You have to have multilingual support clearly, and you have to ensure that you do not leak anything inappropriate, right? So all of this has to be done nicely in your natural language generation systems. Now, people have proposed several kinds of natural language generation mechanisms. This is a non-deep learning based NLG system called Query Blazor, a very recent one. So here, the idea is that you can build a subword level language model, more like a finite state automata, using a custom vocabulary. So this one, basically, while training, it actually builds its own custom vocabulary, subword vocabulary, and then using historical data, it trains a very nice finite state automata in some forms. And then it strikes a nice RAM versus latency trade-off so as to basically show awesome completions for query prefixes using this automata that is built offline. People have, of course, experimented with several kinds of deep learning mechanisms, starting from typical RNNs, LSTMs to more recently transform-based networks. So, for example, people started in 2017 by building character-level language models, where every character was encoded using a one-hot embedding for the character. However, they were also embedded using learned character embeddings or even using word embeddings. So for words for characters that denote an end of the word, you would actually use the word embedding for example, for T or for the space, you would use the embedding for precedent. But then for all other characters which are in between words, right, in the middle of the words, you would basically use INC, a special token called INC, incomplete, as a word embedding. But anyway, this helps to get you reasonably good completions. Well, sometimes it does not really work that well, but in general, it gives you reasonably good completions. People have also experimented with hierarchical RNN models where you would give some importance, where you would basically treat a session as comprised of several queries and then queries as comprised of several words. So you'd use a lower level RNN to actually encode different words in a query and come up with some sort of a query embedding. And then you would basically encode several queries and then use them in upper level RNN so as to encode the complete session, and then of course tie everything in a encoder decoder framework so as to then predict the next query, and then for the next query predict things word by word. People have also tried to look at it from a graph perspective, basically saying that, hey, terms in a query can be related to each other because of consecutive nature. So, baseball matches is a query, so therefore you connect baseball and matches. But then, hey, actually consecutive queries can also be linked to each other, one after the other. And then there could be query term relation. So baseball matches contains the word baseball. And then there could also be nice, interesting click-through information, which could be sort of leveraged as well, right? So thus they build a graph of query term and websites, and then they learn using graph embeddings. They learn embedding for each of those nodes. Now those embeddings basically go as representations for these queries. And then they have this interesting encoder decoder framework, which is basically used so as to predict the next suggestion. However, this framework is very, very interesting because it uses a query session attention layer as well. So you have those queries, you have this notion of reformulations as well. So they basically think of a session as comprised of several queries, where the next query is a reformulation of the previous one. You could sort of model reformulation as a difference between two query embeddings. So if you have like a query qi plus 1 and a query qi, you could say reformulation vector is the embedding for qi plus 1 minus the embedding for qi. And then the idea is to essentially use these node embeddings for queries and use an attention layer over the reformulation so as to do multitask learning with three tasks in mind. You want to predict the next reformulation vector from qi to qi plus 1, the future query. You, of course, want to generate the future query. So there's a query generator also. And then you also want to, given a few candidates, you want to basically figure out whether this candidate is a good next query or not. So this way, they have combined the power of graph-based encodings with attention and with the multitask learning so as to generate the next query. Folks have gone further and tried to essentially model this using pointer generator kind of networks. So copy generator specifically, the idea is that users tend to copy a lot of words from the past just to generate the next queries in their sessions. So for example, consider this user which has 3 queries in the session. And then, when the user is trying to generate the next query, maybe the good idea is to first copy Bob as it is from the first query, then essentially, copy Dylan from the third query or the most recent query in the use session, and then just generate bio as the next word rather than copying it from any of those words in the past. So like an attend copy generate model. You basically have 2 levels of attention, one on the previous queries and then words in the previous query, second one, right? So at every point, you either use the query level attention or the word level attention and decide whether you want to generate the next word or copy it from one of the queries in the past, right? So it's a copy generator. So whether you generate or you copy, you essentially come up with the next word, based on this switch gate, which is of course trained as part of the model. Okay. Lastly, people have tried to, of course, use transformer models, and people have tried transformer models again from a multi-view, multitask perspective. So here the idea is, so multitask perspective is pretty simple. Well, there are 2 tasks here. One where you try to generate the next query, and second where you want to predict the CTR. So if I was generating this particular query, or if I have this candidate, what is the probability that the user will click on this particular query, right? So those are 2 tasks that are being done on the decoder side. But on the encoder side, well, you could basically use 2 kinds or several kinds of past behaviors, right? Not just you could use the session history of the user, but you could also leverage, let's say, browsing history of the user. So the recent trend has been to leverage as much as context possible about the user so as to predict the next query, right? So the behavior that you see here could be the past session query history behavior, or it could be browsing history behavior, right? And you could model those queries or titles of those web pages which have been browsed in a transformer encoder, finally giving you a combined representation of the past history that the user has been doing, whether the browsing history or the search history, right? You use this combination, encoded combination, so as to generate the next query using this transformer encoder decoder kind of a network. Thus, it is multi-view because it's looking at browsing history or session history, and multitask because it's trying to generate the next query as well as predict the CTR. While we do all of this, several times these generative models, especially the deep learning ones, can lead to nasty suggestions. Uh, for example, should I learn to swim is a reasonable suggestion, but should I quit my job or should I end my life is clearly not reasonable. Similarly, there are some unreasonable suggestions which are being shown here. There are several kind of unreasonable things that may be suggested by these deep learning models, right? Harmful speech. You see, I'm not going to read out those, but they are pretty uncomfortable suggestions, right? Potentially illicit suggestions, adult queries, controversial queries, misinformative suggestions, and so on. So especially these kinds of suggestions are much more prevalent in case of search voids. Search voids are rare query prefixes for which not many good search engine results exist. And in these cases, people have found that rare query prefixes tend to be up to 3 times more likely to be linked to problematic suffixes, right? So the idea is that yes, while all of this is good, sometimes these suggestions can be really nasty, and one has to guard against generating such nasty suggestions. Okay, so I'll probably quickly end my talk here with a very brief summary. So in this talk, I talked about 3 different aspects of designing an search autocomplete system, query autocomplete system, right? Ranking, handling defective suggestions and prefixes, and NLG mechanisms and personalization for generating awesome queries. So that's that. Now there have been some interesting trends going on in the community. So people have been trying to explore the use of extreme multi-label classification for query autosuggestion. So you could treat the entire set of queries in your try as a very large set, and you can try to do multi-class classification in that large space, right? People have also been trying to merge the popularity from those tries with the generative language model aspects from deep learning, natural language kind of mechanisms, somehow combine them and come up with a more powerful model. And of course, there have been more efforts on non-toxic generation, somehow avoiding all of that offensive behavior from those deep learning models while suggesting things in your autosuggest system. That's the end of my talk. If you have any questions, comments, please feel free to write to me or connect with me on LinkedIn. Open to questions now. Thank you.